Hey guys, it's Miss Menace. We're doing 2-3 today. Your objectives are using the law of detachment and the law of syllogism. Two new things that we're going to learn. Okay, you have a warm-up, stuff you should already know. Converse of a statement, conditional. Okay, so go ahead and try those. Remember, converse, you switch your subjects. Conditional is just an if-then. Okay, go ahead. Okay, so you should be able to conclude for your converse, switch your grades suffer and switch don't sleep enough. Okay, so if your grades suffer, then you don't sleep enough. Okay, so number 2 should have said, if you must start early, then you want to arrive on time. Okay, so, or if you start early, then you must want to arrive on time. Okay, just scribbling that down. Okay, conditional, you have to put an if and a then in your statement. Okay, so if a year has 366 days, then it is a leap year. Okay. And then number 4, let me move that up. You should say, if students do not complete their homework, then they will have lower grades. So if students do not complete their homework, then they will have lower grades. Okay? Got it. Hopefully you got those right. If you didn't, you really understand what's going on here with converse and conditional. Awesome. Okay, so let's do vocabulary. 3 new things going on here. Number 1 is deductive reasoning. So deductive reasoning is the process of reasoning logically from given statements to a conclusion. If the given statements are true, deductive reasoning will produce a true conclusion. Okay, we'll talk more about that. So, 2 laws here today. The law of detachment states, if a conditional is true and its hypothesis is true, then its conclusion is true. Okay, so remember, your conditional has 2 parts, if P, then Q, right? Oops. Up and top. So if P, then Q here on the side. So the law of detachment is saying that if a conditional is true, so the whole thing's true, and its hypothesis is true, then Q also has to be true. Okay? That's pretty obvious, but there is a law of detachment to show that. Okay, now we have the law of syllogism. It's at the top of your page. Okay, the law of syllogism allows you to state a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis of the other statement. Okay, that's a lot of words. Let's think about it. Two true conditional statements. When one statement is the hypothesis of the other statement. Okay, so one conditional statement, if P then Q. So this happens when the conclusion, Q, of one statement becomes the hypothesis of another statement. Okay? So this conclusion of the first statement becomes a hypothesis of the other statement. Then you can say if P then R. I'll explain that more in a little bit, but that's basically like the transitive. If A equals B, and B equals C, and then A equals C. If P then Q, if Q then R, then if P then R. Okay? So, let's move this up so you can see. And we'll talk about the law of detachment. Okay, we just said this. Deductive reasoning, blah, 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 blah. It's right there. Sorry. That was reprinted. Scratch it out. Okay? So, just to give you kind of a real-world example, many people use deductive reasoning in their jobs. A physician diagnosing a patient's illness uses deductive reasoning, right? Think about that. If you're going in sick and you're dizzy or something, they may conclude that you're dehydrated. Do they know that for sure? No. But they're using deductive reasoning based on the symptoms you told them. Okay? A carpenter uses deductive reasoning to determine what materials are needed at a work site. So he may bring everything to work that one day and would have forgotten 2 or 3, but he used deductive reasoning to figure out basically what he needed to fix whatever job he's working on that day, right? Okay? So an auto mechanic knows that if a car has a dead battery, the car will not start. Let's use deductive reasoning here. So a mechanic begins work on a car and finds the battery is dead. What conclusion can she make? Okay, so here's your statement here. If, and sorry, that should probably say then the car will not start. But there's your statement there that we're going to look at. So a mechanic begins work on a car and the battery is dead. So therefore, what can you conclude? You can conclude that the car will not start. So we're using deductive reasoning to figure that out. Deductive reasoning to figure out the car won't start. Okay? Based on our statement here. Okay, let's move to the next page. Okay, same kind of thing going on here, but a different question, same situation. Suppose that a mechanic begins work on a car and finds that the car will not start. So using the same statement before, that if a car has a dead battery, then the car will not start. Can the mechanic conclude that the car is a dead battery? So let's think of the reverse there. Can you say, if a car doesn't start, can you conclude that the car is a dead battery? Okay, well no, you can't, because there are many reasons why a car can't start. So no, many reasons why a car can't start. Okay, so it's not necessarily that the battery's dead. Okay, so keep that in mind. You're going to use inductive reasoning to figure out that no, you can't just conclude that the battery is dead. Alright, so those are just real world examples for you. Let's look here. In example 1, the mechanic is using a law of deductive reasoning called the law of detachment. Okay? Now let's look more at that. So, if a conditional is true and its hypothesis is true, then the conclusion is true. So, if P then Q is a true statement, the whole thing, and P is true, then Q is true. Okay? So you can use that when we're concluding different geometric statements, different things going on in geometry. So let's look at this next example, because it's going to talk about midpoints of a line segment. Okay, so now we're applying it to geometry. Okay, so for the given true statements, what can you conclude? Okay, so you know it's true. Awesome. If M is the midpoint of a segment, then it divides the segment into two congruent segments. Okay, so if P, M is the midpoint of a segment, then Q, then it divides the segment into two congruent segments. Okay, those are true. So now let's use the law of detachment to move on from there. Here's your hypothesis. M is the midpoint of AB. Okay, so that's your P. Midpoint of a segment, right? Well, here it's just giving you a true statement with a specific segment, AB. So now it's a little more specific. So let's use the law of detachment to make a conclusion about this segment. Alright? So you're given that the conditional and its hypothesis are true. By the law of detachment, you can conclude that M divides AB into two congruent segments. Okay? So M is the midpoint of AB, therefore it divides the segment into two congruent segments. Okay? So AM is congruent to MB. We have A, B for the segment that it was given to you, and M is the midpoint. There's M. So therefore, it's saying that AM is congruent to MB. Okay? And we know that's true if M is the midpoint. Okay, so let's look at an example with baseball. So, if a baseball player is a pitcher, then that player should not pitch a complete game 2 days in a row. So if P, baseball player is a pitcher, then Q, they should not pitch 2 complete games in a row. Okay, so Vladimir Nunez is a pitcher. On Monday, he pitches a complete game. What can you conclude? Okay, so you should conclude it needs to be 2 days in a row where they cannot pitch. So the next day after Monday, which is what you're given, is Tuesday. So you should conclude that Nunez should not pitch a complete game Tuesday. Okay, so we took a vague conditional. If a player is a pitcher, then they shouldn't pitch 2 days in a row, right? Vague. Then we were given a more specific statement here, okay? Vladimir Nunez is the pitcher. And also you were given a specific day, Monday. So use the law of detachment to conclude about your cue and make it specific. Nunez should not pitch a complete game on Tuesday. Okay? So let's look at the next example. Does the following argument illustrate the law of detachment? Okay, let's see. Given, if it is snowing, then the temperature is less than or equal to 32 degrees. Okay, so here's a more specific. The temperature is 20 degrees Fahrenheit. Can we use the law of detachment to conclude this? Okay, so here, we're given if P then Q. The hypothesis here is P. So are we given a specific hypothesis? Or are we giving a specific conclusion? That's what you have to figure out. because the law of detachment is only hypothesis is true. Okay, so if you look at the temperature is 20 degrees Fahrenheit, well, that's really giving a specific or an example of a Q. Okay, so we cannot conclude from the law of detachment that it is snowing. Okay? So think about it. Can it be 20 degrees outside and not snow? Well, yeah, it can. Don't you need precipitation in the air to have snow fall? Okay, or you need some kind of rainfall going on for the snow to actually happen? It can definitely be 20 degrees outside and not snow. Okay? So we cannot conclude it is snowing. Okay? And that's because we were given a specific conclusion, not hypothesis. Okay, so came from Q, not P. This came from Q, not P. Okay? So it also says right there, you cannot apply the law of detachment and conclude the hypothesis is true. Okay? You cannot come to any conclusion about whether it's snowing or not. Okay, hopefully that made some sense. So let's do example 3 here. Same law. And you notice it says if possible because, yeah, it might not be possible. Use the law of detachment to draw a conclusion. If it is not possible to use this law, explain why. Alright, this one may make a little more sense. Here's your hypothesis. If a road is icy, then driving conditions are hazardous. Okay? So here's your not more specific conclusion, but whatever. Driving conditions are hazardous. So can we conclude that the road is icy? Using the law of detachment. Okay, we can't because this is matching Q. Alright, and think about it. If a road is rainy, will driving conditions be hazardous? Yeah, for sure, especially these last few weeks. Okay? So we can't conclude anything. No conclusion. Okay? And again, just think of an example. It's raining outside, so the driving conditions can be hazardous. There's a counterexample right there. Okay, so let's move on and learn about one more law today. The law of syllogism. This is your last page for today. Awesome. Okay. So, here. Another law of deductive reasoning is the law of syllogism. Again, this allows you to state a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis of the other statement. Okay, that sounds crazy, but what are we talking about? Here, if P then Q and Q then R are true statements, then P then R is a true statement. Okay? So think of like transitive. If A equals B and B equals C, then A equals C. Same exact idea, but we're using it with conditional statements. So because of the law of syllogism, we can say this is true. Okay? So let's look at what's going on here with some examples. Use the law of syllogism to draw a conclusion from the following two true statements. If a number is prime, there's a P. Then it does not have repeated factors, there's a Q. Okay, so let's look at the next statement. If a number does not have repeated factors, okay, ooh, that matches that Q, then it is not a perfect square. Oh, that's something totally different. We're going to call that R. Okay, so if these are true, if they're true, then you can use the law of syllogism to say if P then R. Okay, so let's think about whether they're true or not. If a number is prime, then it does not have repeated factors. Okay, yeah, because a prime number is just a number times 1. Those are the only factors. Those can't be repeated. 1 is not prime. Okay, so anything like 2, 3, 5, it's just 2 times 1. Okay, no repeated factors. That makes sense. Here we go. If a number does not have repeated factors like 2, then it is not a perfect square. Well, obviously, any perfect square, like 25, has 2 repeated factors. Always, always, always. Okay? So, yeah, if P then R, that's definitely true. Okay, so here they conclude that. You can use the law of syllogism to draw the following conclusion. If a number is prime P, then it is not a perfect square R. Okay, you know that's true. No prime can be a perfect square. Okay. Only a few more. So let's do example 4. Using both laws. Oh, sorry, no, that's next. Example 4 here. If possible, state a conclusion using the law of syllogism. If it is not possible to use this law, explain why. Okay, cool. So we have, if a number ends in 0, P, then it is divisible by 10, Q. Okay, so you can stop at each statement and say, is that true? If a number ends in 0, 10, 100, 20, 5,000, then it is divisible by 10. Well, yeah, that's totally true. 10 goes into 20, 500, 20,000, definitely. So let's look at the next statement. If a number is divisible by 10, that's a Q, then it is divisible by 5. That's an R. Okay, that's definitely true because 5 goes into 10. So anything divisible by 10 is divisible by 5. Okay? So, what can we conclude using the law of syllogism? Well, we can conclude that P then R, P then R. So let's write that out. If a number ends in 0, then it is divisible by 5. Okay, so we have if P, then R. Okay? So let's look at B. If a number ends in 6, then it is divisible by 2. If a number ends in 6, B, then it is divisible by 2, R. Well, is that true? Yeah. Oops, this is Q, sorry. If P, then Q. Okay, yeah, that's definitely true because same reason here. 2 goes into 6, so something is divisible by 6. It's also divisible by 2. Alright, let's look at this one. If a number ends in 4, then it is divisible by Q. Okay? So, in order to use this law, this conclusion on the first sentence has to be the hypothesis of the next sentence. This conclusion has to be the next hypothesis. Well, that's not going on here. We have a conclusion and a conclusion. This you could call the R because it's new. Alright, so think about it though. If a number ends in 6, is it divisible by 4? Necessarily, no. It's not. Okay? So, what are we saying though? Whether that's true or not, you can't conclude anything. No conclusion. Because this conclusion of the first conditional statement did not become the hypothesis of this next conditional statement. Okay, so didn't use hypothesis here. That's why. Okay, so let's look at the bottom here. Using both laws. So we can use the law of detachment and the law of syllogism together to draw conclusions. So, use the law of detachment, blah, blah, blah. Here's your first statement. If a river is more than 4,000 miles long, then it is longer than the Amazon. Okay? Cool. We have a P and a Q. So the law of detachment will give you another statement. Okay, the law of syllogism will give you a Q then R. So let's see what's going on here. If a river is longer than the Amazon, then it is the longest river in the world. Okay, this looks definitely like the syllogism. Q is repeated. then R. Okay, so now we conclude if P then R. Now we conclude if P then R by the law of syllogism. So I don't want to write that out, but you can now say if a river is more than 4,000 miles long, then it is the longest river in the world. Okay, so now this is looking like a law of detachment because I'm given another statement, another thing going on. The Nile is 4,132 miles long. Look, that's a more specific P, right? Okay. So here is your, let's talk about that. Oops, a little bit later. So, if P then R is what we concluded, and it wrote that out for you. If a river is more than 4,000 miles long, P, then it is the longest river in the world, R. Okay, so that's your law of syllogism used here. So with this and the fact up here, use the law of detachment to conclude that the Nile is the longest river in the world. Okay, so since the Nile was longer than 4,000 miles long, it is the longest river in the world. Okay, so now we've replaced P with a more specific river, the Nile, and concluded this R, that it is the longest river in the world. Okay, so let's use that same idea and just do our own example here. So you use the law of detachment and the law of syllogism to conclude something. The Volga River is in Europe. Okay, that's not an if P then Q. So this tells me we may be looking at the law of detachment first. Okay, because this is not a conditional statement yet. Alright, so here we go. If a river is less than 2,300 miles long, it is not one of the world's 10 longest rivers. Okay? If P then Q. If a river is in Europe, then it is less than 2,300 miles long. Okay? This looks like a P, and this looks like an R. Okay, so these two are technically a law of syllogism. So we're saying if R then P for the second sentence, and up here we're saying P then Q. Okay, so is one hypothesis the conclusion of something else? Well, yeah, it is. This conclusion becomes this hypothesis, okay? So don't get confused. Even though your statement with this going on comes second, it's still a law of syllogism because someone's conclusion became a hypothesis. Okay, so actually now we're concluding from the law of syllogism that if R then P then Q, then R then Q. So now we're concluding R then Q, right? Okay, which you could write that out if you wanted, but let's just say what it is. If a river is in Europe, then it is not one of the world's longest rivers. So that comes straight from the law of syllogism. Now let's use this example given from the law of detachment. The Volga River is in Europe, okay? We'll see that's a more specific R. R is a river in Europe, right? So here's a more specific R, Volga. That looks like the law of detachment to me. So if the Volga River is in Europe, then what is Q? Well, it's not one of the top 10. So what can we conclude? The Volga River is not the top 10 longest rivers, okay, in the world, but that's fine, longest rivers. Okay, so that's your law of detachment, law of syllogism put together. Look on the board for your homework for today, and go ahead and get started. Hope you guys have a great rest of your day.